Okay, class. Today we will discuss functions. In particular, piecewise functions and the graphs of quadratic functions. How would you interpret the function on the board?
After 12 minutes, Mr. Amato's rate of muffin eating is down 10/12 per minute.
Remember that functions are evaluated for a given input x, and you get an output y.
Now we will plan a piecewise road trip across the country.
Piecewise functions involve pieces of graphs.
We will map out our route in 3 separate functions, with days of traveling determining which piece of the trip or function we are on. We have one function for days 0 to 2, another for days 2 and 5, and a final function for after 5 days on the road.
The first leg of our journey will involve an absolute value function.
The second leg of our journey involves a linear function with a negative rate of change or slope.
Finally, our last leg involves a horizontal line at f of d equals 5, heading due east to the coast.
Quadratic functions have what we know as key features. We will look at intervals in increase and decrease, the vertex, the x-intercepts, and the y-intercepts.
As we move left to right along the graph, we first go uphill, then in an interval of increase.
As we continue to move along the graph, we get to the highest point and begin to move downhill. This is an interval of decrease.
The x-intercepts are also known as zeros or roots because the y value is 0. It is where the graph also crosses the x-axis.
The y-intercept is where the graph crosses the y-axis. It is also given by the c-value or the constant in the quadratic function in standard form.
The vertex is the highest or maximum point, or the lowest point known as a minimum. A function is a continuous if you can trace the whole thing without picking up your pencil.
Domain is all the possible x values for a function. This function has a domain of all real numbers because as we travel along the function, all x values will exist on the graph.
Remember, students, plug the x values into your function to evaluate the function for a given value. Context matters.